A very typical semi-quantitative type of exercise is when we ask you to rank solutions in decreasing or increasing pH. And I'm saying that it's semi-quantitative because the pH scale will allow us to approximate numbers, and we do not need to calculate the exact concentration of hydronium ions. We can more or less decide ranges, and this is what we're going to do now. In this case, is asking for a decreasing pH. First of all, notice that when a pH increases 1, 2, so 7, 10, 14, because pH is the negative log of hydronium ions, a pH 7 means that it's neutral. If your pH is lower than 7, it means that your concentration of hydronium ions is larger than 10 to the negative 7. You have acid, okay? And if your pH is higher than 7, it means you have a basic solution. Okay, so keep that in mind, because when we have to rank the following solutions in decreasing pH, we'll have to go from the most basic all the way to the most acidic. And we have to therefore memorize. We have to classify the following substances as acid, base, or neutral. So, and whether they are strong acids or strong bases, etc., or weak. So, sodium hydroxide is a strong base. Chloric acid is a strong acid. This is hypochlorous acid. This is a weak acid. This is sodium chlorate. Sodium chlorite. I'm going to write it down so that you know what I'm talking about. Sodium chlorate. That is the conjugate base of a strong acid, therefore is a neutral compound. It's neutral because it's a conjugate base of a strong acid, and sodium phosphate is the conjugate base of a weak acid, therefore is a weak base. So notice that the most basic will be the strong base, followed by the weak base, followed by the neutral compound, followed by the weak acid, and the one with the highest concentration of hydronium will be a strong acid. In this case, the concentration is pretty much similar, so you will not see any difference, because in the ranking at least, because of the difference in concentration. Right? So if we were to rank it, sodium hydroxide is the highest pH, followed by sodium phosphate, followed by sodium chlorate, which is the neutral, followed by the weak acid, which is hypochlorous, and followed by, finally, the strong acid, which is chloric acid. Okay. Notice that this is the pH scale. The pOH scale, 0, 1, 2, 7, 10, 14, works in the opposite of the pH scale. If the pH, when pH is 14, pOH is 0. When pH is 13, pOH is 1, so that when you add them up, they are all 14. 12, 7, 4, and 0. Okay, so to do the same ranking in decreasing pOH, we will have to just write the same, but in opposite direction. The largest pOH will be the most acid, and the lowest pOH will be the most basic. Okay, so I'm just gonna write everything again. So this is my strong acid, this is my weak acid, followed by my neutral compound, followed by sodium phosphate, which is a weak base. This is neutral. And finally, the one with the lowest pOH will be sodium hydroxide, which is a strong base. Hopefully you can see that the pOH of a 0.1 molar is of a strong base is 1, therefore the pH is 13. You could do the same for all of them, or actually no, not true. You could do the same for only the strong acids and strong bases. Okay. So what have we learned from this? There are some admitted ranges when it comes to strong acids, strong bases, weak bases, and neutral compounds. We know that a strong acid has to have a concentration of hydronium ion larger than 10 to the negative 7, and therefore the pH has to be smaller than 7. And because this one is connected to this one, so the concentration of OH negative has to be smaller than 10 to the negative 7, therefore the pOH has to be larger than 7. Okay, because these two need to add 14. All right, and the pKa, if a strong acid has a Ka again around 10, it means that probably your pKa is smaller than 0. Okay, and because they have to add up to 14, this has to be the pKb, and you can barely read pKb. The pKb will be higher than 14. Hopefully that makes some sense. Notice that these two are related through the pH plus pOH is 14, and that pKa plus pKb is 14, etc. Okay, what can we say about a strong base? A strong base will have for sure a concentration of hydroxides higher than 10 to the negative 7. Therefore, the concentration of hydronium is going to be smaller than 10 to the negative 7. Okay. Therefore, if you do the pH, this has to be a strong base will have for sure a pH higher than 7. Therefore, the pOH will be smaller than 7. Okay. The pKa, what do we know? Well, we know that the pKb will be smaller than 0. Okay, and the pKa, if this relationship holds true, it has to be higher than 14. This is why the conjugate acid of a strong base is neutral. Okay, the same can be said about weak acids and weak bases. So I'm going to just repeat the same that I wrote for strong acids in the line of weak bases. The only thing that you know is that the pKa is going to be between 0 and 14. The pKa is going to be between 0 and 14. 0 and 14. And the same for pKb. pKb will also be between 0 and 14. Okay, and for the weak base, you're going to do the same in here. Repeat the same line. Okay, and this will be true also for a weak base. For a neutral compound, however, 10 to the negative 7, this is 7, 10 to the negative 7, this is 7, and depending on either your pKa or your pKb, should be higher than 14. Okay, depending on if you relate it as an acid or a base. It cannot be both. Okay. All right, we will practice more in class, but please try to stop the video here and rationalize all these numbers. I know I went very fast through this, but make sure that you can understand each and every one of the ranges of pH and pOH, pKa's and pKb's.